Today we'll be reviewing sequences. So in the first problem, consider the following sequence of dots. At 1 minute, you can see how many dots there are, and then at 2, and then at 3. So A, can you make a table for the sequence? So we can see at 1 minute, time 0, we don't know, but at 1 minute, there are 3 dots. Oh, let's make that thinner. At 2 minutes, there's 1, 2, 3, 4, 5, 6 dots. At 3 minutes, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 dots. So we can use this pattern to figure out how many dots there'd be at 4 minutes. It looks like to get from one number to the next, we're multiplying by 2. So if we continue that pattern, there would be 24 dots in the fourth figure. We can go backwards, and instead of multiplying by 2, we could divide by 2, and if there was a time 0, there would be 1.5 dots. All right, so expanded form, this would be 1.5. This would be 1.5 times 2. This would be, oopsies, let's do it again. This would be 1.5 times 2 times 2, and so on. All right, so it says write the recursive equation for this pattern. All right, so the recursive equation is we could start at any term. So I'll just start at the first term and say the first term is 3. And then to find any term, we could take the one before it and multiply by 2. Another way to write that is a sub n equals a sub n minus 2, usually put the number first, 2 times a sub n minus 1. So there's 2 ways to write multiply by the previous term. And remember, a sub n minus 1 means the previous term. All right, can you write the explicit equation for this pattern? Okay, so there's 2 ways to write this. We can start at the 0 term right here. We start at 1.5. And then if you notice, the time matches how many 2's there are. So we can multiply by 2. It's doubling for every minute, if these are minutes, or for every time. So here at time 1 there's 1 2. At time 2 there's 2 2's. At times 3 there's 3 2's, and at time 4 there's 4 2's. So this is one way that you can write it. There's another way you can write it though. So let me switch colors. Or you can start at the first term, because really here we can see the first term there's 3 dots. So there's 3 dots first, and we're going to double it. But if you notice, it can't be n anymore, because if you take a look at, if we're starting at 3, when we plug in a 1, we want to get the 3. So if you choose to start at the first term, you're going to have to subtract 1 from n. So you can either start at the 0 term, or you can start at the first term. But if you start at the first term, it's n minus 1. And then notice the common ratio is the same for both. And then again, it's either n or n minus 1, depending on where you start. So then D says find a sub 7. So what does that mean? It means how many dots are at 7 minutes. Okay, so then using our equation, and there's 2 of them, so I'm going to use both. Here's the first one, y equals 1.5 times 2 to the 7th power. That would give us our answer. I'm going to type that in because I can't do that in my head. So I'll do 1.5 times 2 to the 7th power. Looks like 192. Let's make sure I type that in right. 2 to the 7th power times 1.5. Okay, so that's correct. You should get the same answer if you use the other equation, which is 3 times 2 to the n minus 1 power, so 7 minus 1 is 6. So if you type in 3 times 2 to the 6th power, you'll get the same thing. So that's what I mean by you can use either equation. If you start at the 0 term, it's just to the n power, or if you start at the first term, it'll be n minus 1. Okay, let's take a look at the next sequence. All right, again, it asks for the 0 term, but this one's starting at the first term. So there's one box, or one cube in the first figure, 3 in the second figure, 5, and then 7. So you might ask yourself, what type of sequence is this? And I forgot to ask here, what type of sequence is this? In the dot sequence, if we're multiplying by 2, this would be geometric. So the common ratio would be 2. And right here, it looks like we're adding 2 every time. So this is arithmetic. The recursive equation, you could take any term, like the first term, and start there. So first term is 1, and to find any term, take the term before it and add 2. And then write the explicit equation for this pattern. Okay, so we know that if this is linear, we can use slope and y-intercept. And so the y-intercept, you'd have to go backwards 1 to start at times 0. So instead of adding 2, you'll subtract 2. And the y-intercept is at -1. So we could write y equals -1 plus 2x. If you want to write it in function notation, we'd say f of n equals -1 plus 2n, where n is the figure number. So 2 ways to write that as well. And again, what does it mean when you are asked to find a sub 7? It means what's the 7th number in the list, the 7th term, we could say. So I would use the explicit notation instead of just adding 2 every time. So to find the 7th number in the list, it's -1 plus 2 times 7, which would be 13. So a few ways to get that, but that's one way you can plug it in. So review, and we're just in class going to come up with sequences. Let's do an arithmetic one. Let's do one where we subtract. So let's do like 99. And let's just subtract 2. We do 2 all the time. Let's do 3. So 96, 93, 90. Here's an example of an arithmetic sequence. The common difference is -3. The recursive rule is, the first term is 99. To find any number, we take the 1 before it and we subtract 3. The explicit rule, we need slope and y-intercept. So you'd have to go backwards 1. And so instead of subtracting 3, you would add 3. So 99, 100, 101, 102. So the explicit rule, I'll write in function notation. To find any number, you start at 102 and you subtract 3 every time. And then to find the 11th number, I guess they're writing it like this. So I'm going to change how I write this one so it matches. Okay, so to find any number, we take 102 minus 3 times that number. So then to find the 11th term, it's 102 minus 3 times 11. Okay, so what's 102 minus 33? 69. So we'd say that the 11th term is 69. Okay, let's do a geometric. Let's do one where we're dividing by a number. So let's take 200, 100, 50, 25. All right, the common ratio, we can say divided by 2, but we're looking for a number that we're multiplying by. So this is multiplying by 1/2. So the recursive rule is our first term is 200. To find any number, we take the number before it and multiply by 1/2. Or you can write, to find any number, we take 1/2 of the number before it. So I squeeze that in there. All right, the explicit rule. Okay. To find any number, we start at, I like to, okay, let's start at the first term. So if you start at the first term, we're multiplying it by 1/2 every time, but remember the first term, you have to do the -1. So then to find the 11th term, it would be 200 times 1/2 times 11 minus 1, which is 10. And if I type that in, okay, times 200, I'm just typing in my calculator, So the 11th term is really small, about 0.195. I should put wavy lines. Okay. So there's a quick review of what we've been doing the last week and a half.